Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 18 of the November Daily LeetCode Challenge, and this is the first time that we have an easy question in November Daily LeetCode Challenge. Yesterday, like just to inform you, we had a hard question for the first time in November Daily LeetCode Challenge, and it was a very nice question. I have given you multiple approaches for that in yesterday's question in my videos, and I've also given a solution which is even better than the solution given by LeetCode. Okay, so you may go and check that out. Okay, that was day 17 of the November Daily LeetCode Challenge. You can go and check that video out. But this question is easy, so let us quickly see what this question is. But again, just a reminder, if you want to learn something new, I see this is a question, but yeah, in case you have not seen yesterday's video, you can go and check that out. It was a really nice question, and you will be feeling proud when you solve that question. And if you see my video, I've given even optimal solution than the lead code solution. Okay, so let us start this question now. So as you can see, we are given a code array and we are given an integer k. We have to return a again integer array as the output. Okay, if you see here, what they're saying is you have a, okay, let me zoom in first so that you can get a better idea. You have a bomb to defuse. Your time is running out. Your informer will provide you the, okay, so these are fine. What we'll see what it is. So what we have to do is see, you must replace every number. All the numbers are replaced simultaneously. Okay, we'll see that. But see, there are three things here. Okay, based on k is positive, negative, or zero, there are three things. First thing is, if k is positive, what you have to do? Replace the ith number with the sum of the next k numbers. Okay. Similarly, if k is negative, you have to replace the ith number with the sum of the previous k numbers. Okay, see the difference that here it is next k, here it is previous k. Okay, and if k is zero, you have to replace every number with zero. Okay. So let us see the example to get a quick sight of what they are doing. So see, in this case, k is positive. Okay. So yeah, what we have to do, for every number, for example, this particular 5, what you have to do, you have to replace 5 with 7 plus 1 plus 4. Okay, if you see here, 5 is replaced with 7 plus 1 plus 4. Okay, similarly, this particular 7 is replaced with 1 plus 4 plus and this previous 5. Okay, so I did not, but one thing that I did not tell you is that it's a circular array. Okay, so this is again one thing that I think I did not mention. It's a circular array. That means if you are crossing the last element, you have to go back to the first element. Okay, that is the basic idea. So if okay, let me zoom in again. So if I talk about this particular 7, so what are the next three elements? 1, 4, and 5. Okay, 1, 4, and 5. So you have to replace with 1, 4, and 5. Similarly, if I talk about this particular one, what you have to do? You have to do with 4, 5, and 7. Okay, 4, 5, and 7. Okay, as simple as that. 4, 5, and 7. Okay, and next, if you are at here, what you have to do? You have to replace it 5, 7, and 1, and that's what they are doing. Okay, so this is the case when k is positive. Let us see a case when k is negative. Okay, we'll come to this case where k is negative. What you have to do? See, this particular element you have to replace with the last two elements. Okay, so that is 3 plus 9. Okay, 3 plus 9. Yeah, that's what they're doing. Similarly, this particular 4 you have to replace with 2 plus 3. Okay, how to? Here it is 2, and then one more element left of it. It's 2 plus 3. If you see here, that is how it is done. Okay, so that is what the question is. See, whenever k is positive, you have to replace with the next k numbers. Whenever k is negative, you have to replace with the previous k numbers, and you have to follow the circular. That is, you have to assume that the array is circular. Okay, whenever k is 0, you have to replace every number with 0. That is the very easy case. You see here, what you have to do, every number you have to replace with 0 when k is 0. Okay, so see, the thing here is n is going to be very small. That is the reason why it is called as an easy question. Okay, and it's very small. And if you see the k is going to be between, if you see, it's going to be between negative of the n minus 1 and positive of n minus 1. It is going to be within that. Okay, so since n is very small, you can try the brute force approach and get this done. Okay, and other approach will be the sliding window approach, but I want to show you something different. So just in case that you have not seen this, I will show you something different which you will not find usually in this kind of questions. I will show you the prefixum approach in this. So what I'm going to do, see what I'm going to do is, let us say this is the code. Okay, let me zoom in again because yeah. So this is the code. Okay, 5714. It's a four elements are there, and k is 3. So what I will do, first of all, see, this is the 5714. What I'm doing is I'm rechanging the array. That is, after this, I am adding next three elements after 4. Okay, so after 4, if you see here, 5714 is the array. After 4, I'm adding the next three elements. Why 3? Because k is 3, right? So if you see here, 5714, after that, I added 57 and 1. Okay, how I got them here, 57 and 1. Similarly, since k is 3, what I have to do, I have to add the previous four elements as well. Okay, so if you see here, 571, what are the previous four elements? It is this one, 4, 1, and 7. Okay, 4, 1, and 7. So this way added. Okay, as simple as that. See, there are many ways to it. I am showing you something that is slightly complex. Okay, see, you can use a brute force approach, you can get the answer. You can use the sliding window and get the answer. See, there are multiple ways to do it. Okay, but I just want to show you the prefixum approach in such a way that it is really optimal. I'm using a space, I'm using O of n, but yeah, that is fine. but yeah, it will be running very fast. Okay, if you see that time complexity of this, it will be open, it will be really fast. Okay, compared to other ones where we are doing the in place calculation, it will be fast because here I'm already calculating the things, and while calculating the answer, I will just doing a subtraction, getting the answer. Okay, I will not be revolving around the area to calculate those things. Okay, that's why it is faster. So I hope you understood this part. So left of my given number array, I'm having three numbers. Similarly, right of my given this array, that is this array, I'm having the next three numbers. Okay, what I'm doing is I'm calculating the prefix sum. Okay, if you see what it is, 7, it is coming as it is. Then here next element is 1. Okay, so what I will do, 7 plus 1, which is 8. Okay, as simple as that. Okay, here the next element is 4. So what I have to do, 8 plus 4, you have to get 12 and so on. Okay, so I am doing this. So I am calculating the prefix. Okay, let me quickly run this and show you. So after I get the prefix, then it is very very easy for me. See, this is the array. Okay, what I did, I just for example in this case, case 4. Okay, let me go to a simple example. Yeah, here. So 8, 5, 7, and 4 is here. I added next three elements and the previous elements for it. Okay, because k is 3. Okay, because k is 3. What I did next, I found the prefix sum. Okay, the prefix sum of this, and then the things are very very simple, as you might have already guessed. Things are going to be very very simple after that. Okay, let's see the code now. So if k is 0, what you have to do, simply make a array which has 0 elements for n times and return it. Okay, simple as that. What is n? N is the length of the code. What you have to do next, I am calculating the modified nums. What is modified nums? I will have the given array, and the right of it and the left of it I will have k elements extra. Okay, that is what I'm going to do next. I'm calling it as a kk. In case like if k is negative, I need to negate the k and take the k of it. Okay, so that k remains positive for me. That's because I need that, because I need to do this kind of operations. Okay, so what I'm doing, first of all, calculate the existing elements in code, transfer it to modified nums. Okay, next one I'm doing in the modified nums, that is append k elements to its right. Okay, similarly here, append k elements to what is left. Okay, these are the two operations for that, to append k elements to its right and k elements to its left. Okay, after that, what I'm doing, I'm just calculating the length of the modified nums. Okay. Then I'm calculating the prefix sum. Okay. Initially everything will be 0, and then on first element will be the given element itself. After that, from the first element onwards, I will calculate the prefix sum of every other number. Okay. So every number here, I will be calculating the prefix sum. Next, what I'm doing now, start the answer calculation. Okay. Here is the answer array. What I'm doing next. Here I'm going through the given nums, that is the actual array given to me. Okay, this particular array, what I'm doing, I am doing the calculations in a way to get the prefix sum. Okay, so if k is greater than 0, I have to do just this operation. If k is negative, what I have to do, so remember k equal to 0 is already covered, so k will not be 0 by the time we are coming to this part of the code. Okay, so whenever it is we are coming to else part, it is k is negative. Okay, for I equal to 0, the slightly different case. For all other cases, you have to follow this. Okay, so how I am getting this? See, it's very simple. For example, I am here. Okay, so what is this? It's basically I plus k. Okay, it's basically I plus k. So I'm doing the same thing here. It is I plus k. If you see here, what I have to do, I have to I want the sum of the next three elements. So I'm doing I plus k and again a plus k, and then I'm subtracting from I plus k. Okay. So the idea here is, if you want the sum of the next three elements from here, what you have to do, you have to subtract basically 29 and 17. Okay. That is how I am going to do it. Okay. That is the basic idea. Similarly, when k is negative, what I have to do, for example, I am here. What I need the sum of last three elements. Okay. What I have to do, I have to subtract 17 and 7. Okay. I need to subtract 17 and 7 to get the sum of these three elements. I hope you understand. See, I am at 7. I need a sum of previous three. So what are previous three? Previous three are these things. Okay. So what I have to do for that, I have to subtract 17 and 7. So that's what I'm doing. So I plus k minus 1, which is, see, I am at 7. So what is the previous element? It is I plus k minus 1. Okay. Similarly, what is the this particular thing? You have to again do a minus. Okay. If you see here, I plus k minus 1, again minus k. See, this thing can be simple. See, it is plus k, it is minus k. So both of them will be removed. Okay. But just for your easiness, I am writing it so that you understand how these things are coming. Okay. As simple as that. And finally, we are returning the answer. Okay. As simple as that. Let me quickly run this and show you. I've also included an edge test case. Okay, you can maybe note it down so that if you are able to clear this particular test case, your solution will be accepted finally. Okay, so yeah, as you can see, my solution is working for all the four, and this is one of the edge test case. Okay, one of the last test case that you will be, your code will be facing while you segment the solution. Okay, so yeah, I have included that and it works. So yeah, friend, that was all for today. So see, this question, as you saw, the time complexity, that is, sorry, not the time complexity, the constraint is very very less. So you can try the brute force approach, first thing. Second thing you can do is you can do the sliding window approach. That also you can try. That is simpler one, but I showed you something which is more complex. Okay, but it makes more sense here, because see, even if the case, and that n increases, let us say it is in the range of 10 power, yeah, 10 power 5 to the range. Okay, even then the solution will work, but remember, other solution will not work in that case. Okay, why? Because what is happening, this is OFN solution, that is, even the space and the time complexity, both of them are going to open. If you ask me why, let that, see, So basically, what is happening? I have 5714. Okay, I am incrementing the previous k and the last k. So ultimately, how big it will be? It will be almost, see, still the space only will be O of n only, right? Okay, whatever be the value, okay, see, at max, well, k can be n minus 1. Okay, so I will have n minus 1 towards the right again and n minus 1 towards the left again. So it will be 3 times of this given n. Okay, so still it will remain O of n only. And if you talk about the time complexity will be really, really efficient, because we are, if you see, this is what is happening in the runtime. Okay, so these things are done previously, but this is happening at the runtime. What I'm doing, I'm just doing a difference, subtraction, and I'm getting the answer. So this solution will be really helpful when this particular n increases. Okay, so but yeah, I understand that. I just want to show you the application of the prefixum, so I did the solution. But yeah, like, you can also go for solutions like the sliding window approach. That will be better. But remember, the space and time complexity still remains the same. Even that and this, I have the same space and time complexity. So yeah, I think that was all for today. But once again, like, if you really want to learn something, I again understand this is an easy question. I will definitely recommend you to try yesterday's question, that is day 17 question of the November Daily Code Challenge. It was very nice question. In my video, I have given a solution which is even better than the LeetCode solution. I can write it and give you, it is better than the LeetCode solution, and I've given a proof of that in my video. You can go and check that out. You will really get a lot to learn in that video. Okay, this question was easier, so you can spend some time in that question. Okay, that is yesterday's question, day 17, November Daily LeetCode Challenge question. So often that was all for today. See you tomorrow. Thanks a lot.